Bismillahirrahmanirrahim. Welcome to my channel. And today we will be learning some more examples of exponent, like integers exponent or integers. But before starting, once again, we will say about the COVID-19 precaution. What we have is isolate at home to avoid spreading illness to others. So we are isolating ourselves, and we are also advised to follow the local public health authorities. So we have to help with each other, and we have to help with ourselves not to spread this coronavirus. So stay home, stay safe, stay alert. And what we will be doing today is exponent rules, but the application is on integers. So how sometimes students are like confused with the negative power. If negative power is inside the parenthesis and there is even power, then what happened is negative also goes 4 times with the number. So that means -2 times -2 times -2 times -2. And by algebra, we know that negative times negative is positive, and positive times negative is negative, and again negative times negative is positive. So then we do the numbers, 2 to the 4, to the 8, to the 16. So plus 16 is our answer. So what you need to learn is that negative times negative is positive, and positive times negative quantity, if they are timings, right? If they are multiplying with each other, positive quantity multiplying with a negative quantity, it becomes negative. So the rule in terms of power or exponent, we can say that if negative has got an even power, is their even number, it turns out always positive. So you don't have to worry about the even. If it is an even power, don't worry about the negative sign because it turns out positive. So anytime you have this negative, so here -2 to the power 4, we turn out as positive 16, right? But if negative quantity has got an odd power, odd number, then the answer will turns out as negative quantity. So this is like a general rule that what we will get when we have a negative quantity raised to the even power will be positive. When there is a negative quantity raised to the odd power, it becomes negative. So positive and negative. So you have to remember this. If I have a question like -2 to the power 5, now it is the odd power, that means my answer will surely be negative, right? And if you raise 2 to the power 5, it's not 2 times 5, it's 2 to the power 5, means you have to multiply 2 by 5 times itself. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And I am not worried about my sign because now I learned the rule that if there is odd power on a negative sign, then the answer will be negative, and I am putting negative here, and then I multiply the number, which gives me 32, right? So if we have negative sign outside the bracket, then outside the bracket will also treated as a negative sign, and then we have to multiply whatever we get inside the bracket. So if I have -3 whole square, that means my answer inside the bracket will be 9 plus 9 because it's an even power, but this minus sign will make it again negative. So my answer will be -9, right? So you have to be careful that if there is a negative sign outside. Now if my question is negative to the power 3, third power, so now my outside bracket will negative sign will stay the same. I have to deal with the bracket first. So now negative has an odd power, so that means my answer this time will be 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, but with the negative sign because my power is odd. When my power is odd, my answer is negative. So now this times a negative is standing outside of the bracket as well. So minus times minus is plus. So this time my answer is plus 27. So students have to take care of these sign, whether they are inside the bracket or they are outside the bracket. So we have to deal it accordingly. So if it is minus 2 to the power 4, what will be the sign outcome? Sign outcome will be, because it is even power, sign outcome will be positive. And whatever number you go to 4 times, right? So 2 times 2 times 2 times 2. What you have? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So you have 16, but of plus, right? So these are the few examples where students need some help, because they confuse where to go. So now you can have this, for example. So now this minus sign is inside the parenthesis. That means this will become a positive, because this is a positive, and this is a even power. So positive. So answer will be positive. 5 times 5 and 10 times 10. Right? So you don't worry about the sign, because you know the rule that it will be positive. So 25 divided by 100. Right? And then you can, of course, simplify it to the reduced form, which is 1 over 4. So in this way, you can deal with this question. So a few more examples, we will deal with the integers, so that we are clear about the rules for exponent rules are also called exponent laws. So we will be dealing with some more example here. Let's see if the question is like something like that. 1 over 2 to the power negative 2, right? So we have the rule, right? So negative exponent, that means negative exponent rule says that if you have a negative power, it can be written as in the denominator with the positive power. So my question will turn out as this. Now I have a positive power. I don't worry about now negative power, because I apply the rule, negative exponent rule. So now I have to apply the same minus times minus, right? Minus half times minus half is an even power. So that means it will turn out as positive. So it will turn out as positive 1 over 4, right? Negative times negative is positive, positive 1 over 4. But when it's is a fraction over a fraction, that means 1 over 1, and this will turn out as 4 over 1. So because it is in the denominator. If I want to shift it to the numerator, it becomes 4. So my answer will be 4. So I hope you understand this example. We can deal another example, something like this. If 1 over w to the power 5 to the power 2 times 1 over w to the power 2 and cube, right? So this time I have 1 over, now w to the power 5 and 2 is, so here is the same thing, which is this, a to the power x and over b to the power x. So 1 is 1, so 1 to the power 2 remains 1, but the w will go as like 5 times 2 by this rule, because the exponent rule says that power to the power will be multiplied. So 5 times 2. And here w to the power of 2 times 3 is 6. But they are same base, so we can write they are multiplying with each other. And multiplication rule or the product rule says that power gonna be added. So w to the 10 plus 6. Therefore, my answer will be 1 over w16. So this is another example. I hope you understand these two examples, and there are a few more examples. We can student have questions like this: 3 to the power 3 minus 10 to the power 2. Now 3 to the power 3 or 3 cube means 3 3s are 9, and 9 3s are 27, right? So 27 minus 10 square, so minus and a square, that means inside will be a positive, But because of this minus, I have to subtract it. 10 to the power 2 means 10 times 10, which is 100, right? So now 27 minus 100. That means I have to have a minus sign because minus quantity is bigger than the positive quantity. So I have to subtract it. If it would be 30, my answer will be 70, but it is not 30. So my answer will be 73, right? So negative. Why negative? Because my negative quantity is more than the positive quantity. This is how you subtract on the number line as well, right? So this is the base of the algebra as well. When we do the number line, you can see if I have something like this, right? Let's say I have a question like this, the 7 minus 10, right? So 7 minus 10 means I have to go first positive 7. 1, 2, 3, 4, 5, 6, 7. So I am at 7. And then I have to go negative 10. That means other way. This is my positive side and this is my negative side, right? This is my negative side. So now I have, I covered plus 7. Now I have to cover minus 10. So which way I will go? I will go negative side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I come here, I saw my number is here minus 3. So that means if positive side is less, see here is less and negative side is more. So my answer becomes negative because I all the way covered that positive part and then I enter into the negative part. So my answer is negative 3. Negative 3 is my answer, right? So similarly, here 27 minus 100 means minus 73. So we can deal with some other examples as well. Let's see. So these are some examples where student needs some clarification. So I am explaining it to you here again. So let me clear all of this. So now maybe in decimal terms, if you have something like 0.2 to the power 3, that means 0.2 times 0.2 times 0.2. So you have to multiply 2 by 2 by 2. So 2 to the 4 to the 8. 8 will be there, but you have to put the decimal as well. And decimal is 1, 2, 3 after 3 digits. So 1 digit is here. So you have to place zeros because you have to make 3. Decimal is coming after 3 digits. So decimal, the simplest rule is that whatever power is there, if there is a decimal and there is only 1 digit, of course, then you can do straight, right? Or you can count here 1, 2, 3. So your decimal is after 3 places. Or if I have 0.1 to the power 4, so now I have to do 0.1 into 0.1 into 0.1 into 0.1. So 4 times, but 1 multiplied by 1 doesn't change one value. So 1 remains 1. But I have to place the decimal after how many places, right? 1, 2, 3, 4. Same as the power, right? So 1 is here. 2, 3, 4. Now my decimal is here. So hope you learned this. So 1 doesn't change its value when we multiply 1 with 1, right? If you have, for example, 0.5 whole square, then you say 0.5 times 0.5, which gives you 25, but where your decimal is after 2 places, right? So your answer is 0.25. So similarly, if you have something like this, that 1 to the power 10 minus 9 to the power 1. So 1 to the power 10, 1 to any power does not change the value of 1. 1 remains 1. And if the power is 1, that does not change the base value. So 9 to the power 1 remains 9. Please remember this, that if 1 is raised to any power, it does not change the value of 1. And if 1 is in the power, it does not change the value of base. So 1 to the power 10 is 1 minus 9 to the power 1 is 9. So 1 minus 9 is minus 8. This is your answer. Again, another question or example is 0 to the power 7 minus 1 to the power 15. So 0 to the any power remains 0, right? It doesn't change the value of 0. But 1 to the power 15 does not change the value of 1 as well. So that means that remains 1. So 0 remains 0 and 1 remains 1. So my answer is minus 1, because 0 minus 1 does not change. Value of minus 1 remains minus 1. So anything like this you can have for practice. 2 power 4 divided by 2 power 3, or 2 power 4, sometimes this is 2 power 4 divided by 4 power 2. So this is like 2 power 4, 2 times 2 times 2, 2 times 2 times 2. So 2 times 2 times 2 times 2, 4 times itself, divided by 4 to the power of 2. So 4 times 4. So if you multiply those together, they become 16, and denominator also becomes 16. So your answer is 1, right? This time your answer is 1. So if you take another example, maybe it can be asked like this: 3 to the power 2 times 2 to the power 3. Now 3 times 3 is your 3 square, and 2 power 3 means 2 times 2 times 2. So 3 times 3 is 9, and 2 times 2 is 4 times 2 is 8, and then 9 times 8 is 72. 72 is your answer this time. So questions like this, like integers or when raised to the certain power, you have to apply the same rule, like the same in algebra or alphabetical orders. Hope you like the video. If you like it, subscribe my channel, press the bell icon button. Thank you for watching.